All right, our last speaker is President and CEO of North American Operations at Roshman Group. Before joining Roshman, he had held roles during his 22-year career, such as VP of North America at Tianjin North Glass, VP of Business Development, Sales, and Engineering at APG, and Global Business Development Manager for Structural Glass and Facades at Dorma. He is a civil engineer by trade, also an Association of German Professional Engineers, and a founding board member of the Façade Tectonics Institute. So please welcome Dirk Schulte.
Thank you. Thank you for being here. We all know it's the last presentation of the day, and it's hard to keep yourself up. So I'm glad that you're still here and listen to my presentation. Thank you, Peter, for actually opening the door for corresponding renovation, retrofit, and reimagine of already existing buildings, because that's something what I will be putting my focus on today as well. If that works, right now it doesn't work with the presentation. But we will be probably getting this technical problem solved swiftly in order to start. So first of all, I want to put emphasis on the topic which we are talking about. So we are talking about architectural challenges and solutions, right? So the architectural challenges and solutions which we are facing nowadays are more or less endless, related to already existing architecture as well as new builds and new architecture, where we always have the possibility to create something where we are using a recycled or renovated component from the market as well as from the architecture which is already existing. So in our world, we are looking into more populated areas where we are starting with thinking how we can recycle, how we can reimagine the architecture. And us, from the glass and glazing, from the facade industry, we're always trying to assist in the entire problem-solving process. So first, just want to tell you where we are coming from. Roshman is a facade contractor, usually taking care of high complex and engineered facades in order to create a constructible solution for the architect's dream, which is creating our world of the built environment. We are located in Germany, we are branching out in different markets, and we are typically starting in projects very early in order to assist the architect on creating his imagination and turning this imagination into reality. So, and first I want to start with a thesis. A thesis where we are in architecture with glass. So the thesis is that in terms of creating open areas which are as transparent as possible, the use of glass in architecture could be emphasizing on the value, comfort, as well as the inhabitant quality, only being combined with the basic of design and function. In that particular way, we can create facades, lobby storefronts, skylights, and all these different structures out of glass, which are attracting a kind of visual appeal, window display, natural light, transparency, and branding. And when we are taking this back, what we are thinking of is how can I actually emphasize on the use of glass and creating this concept of using the glass as a functional element which enhances the use of the building. And if we are talking about storefronts, how we are calling them, or lobby facades, we are thinking of all these different items and all these bullet points are becoming a reality, because if I'm using glass as a functional element in storefronts, I can actually brand myself and bring transparency, natural light into the building in order to create an environment where people are feeling good, which also supports the use of the building. And this thesis can be proven in the market, in our architectural world. And it's especially being very prominent in retail. Thinking like, what can glass be in order to brand a company or a further development? Could be creating a complete new solution for a kind of structure which is going in combination with the products a company is providing. But what we don't want to talk about today is new builds, because this is a new build, right? What we talk about today is retrofits, where it comes back to how can I actually renovate and reimagine the built environment as existing architecture. And that's the example what I'm giving you today, just hopping onto the train where Peter left with these different examples which he has provided to us. In this particular case, I'm taking you on a journey of a real project where the existing architecture has been turned into a complete new reimagination. So, and the case we are talking about is the CME building, the Chicago Mercantile Exchange in Chicago. And this building has been built in 1987. Not really long time ago, but still, you know, we are talking about 25, 30 years. And when we are thinking about, well, you know, how long do we actually, you know, think of taking these buildings and resisting on these buildings? And how long are we using the materials which are on these buildings? So typically the buildings are built for a 100-year time period. But are we actually using these products which are on these buildings for that long time? No, we don't, right? And 30 years is a very typical time stretch where we need to rethink after the lifespan of these materials, whether they are still fitting to the use of the building. And in this particular case, this prominent building is constructed out of two towers. We do have two 40-story towers, which are connected with a 10-story center building. It has been designed by Fujikawa Johnson. As I said, built in 1987, and it's still a very prominent building in the financial district of the city of Chicago. And coincidentally, it's the 87th tallest building in Chicago, so which has nothing to do with the year it has been built. So the owner of this building, which is Tishman Speyer Retail Real Estate, wanted to create something with this building in order to compete with the new structures, with the new office towers, with the new commercial real estate, which is being built in Chicago. So he said, well, you know, we need to create something. We don't want to strip the entire window wall of the building because that's too costly and we don't really need to do that. But what can we do in order to make this building more attractive to future clients, to future tenants, in order to get this building filled? That's what we want. That's, you know, where our major business is on. So what can we do in order to convince a future tenant not to rent a space in that new build tower next door, but rather come to our building and feel good and have the possibility to actually represent himself? So, and that's what he, you know, has put out into the market. The building has a about 30-foot, 8-meter tall storefront around the podium. And as I said before, it's a prominent location. So this storefront is creating a space inside of the building which is quite dark. It creates many shadowed areas, corners. There are a lot of plant buckets everywhere. This podium of the building is kind of like a labyrinth where people are going in and not finding themselves. There were bikes which were stored in this podium where everyone actually wanted to get out as quick as possible if he could have found the exit throughout all these different corridors inside of that lobby. So Tishman Speyer said, well, we are understanding that we need to do something, right, in order to get this 1980s style off the table and create something which is astonishing. So they put this out to Crook Sexton Partners, which is an architectural office in the city of Chicago, and asked them, what can we do? What can we do in order to create a total different environment for this particular lobby, which should be warming, welcoming the people, as well as the public environment around that building. Because this building also sits right on the riverfront. So there's a river where people can sit outside and enjoy the time. So Crook and Sexton came up with an idea, right? So all these architectural ideas are creating a kind of enlightened environment in that lobby area, which gets the natural light into the building. And this building, if you think about how this building is located in a very dense area in that financial district, not only are high-rise buildings next to it, so there is a very difficult situation where natural light gets into this lobby, but there is also a large overhang which creates a shaded area, which is another distraction for getting natural light into that podium. So that's why they wanted to get it opened up. They wanted to get it as transparent as possible in order to get rid of any distraction which may also shade the light which is coming in. So that was their concept. And that was 2016. And 2016 compared to 1987, of course, from a material point of view, we do have different technologies of how we are getting to the point of creating those spaces with the least of the materials. So first of all, we wanted to get a kind of understanding of what the architect wanted. So the building is located in that area, and there is a lot of traffic, a lot of foot traffic, which is going around the building. And if you take a look at that center picture, this is how the storefront as well as the lobby was created in 1987. And when you take a look at the right side, this is what the architect wanted. He wanted to have a flow of public traffic going through the building and actually also using that space in that lobby as a collaboration space in order to get people into that lobby and collaborate rather than going up into the offices, but collaborate right at street level in order to have a space which can be used for several purposes. So, and the architectural design criteria which has been set was starting with a storefront which was not straight but kind of curved in order to create vibrance around that building. So this vibrance is pulling the people who are going around and walking around that building closer to the building where it is becoming more attractive. So they were using curves in order to create this kind of shape. Then secondly, they wanted to have floor-to-ceiling glazing, right, in order to get rid of all these distractions. They wanted to have floor-to-ceiling glazing, which was spanning a height of 24 foot, which is 7.4 meters. And then they wanted to have at least material distraction as possible. So, and they created a concept of not using any aluminum or steel mullions. They wanted to have a true structurally bonded component, which is creating that support structure for that front vision glass. So what you do normally, you're starting this in a very early design stage with a design assist or a PCSA, depending on where you are, and you're taking a look at what can we do with the material and the technology nowadays. So what technology is being given to us in order to achieve this architectural vision. And secondly, how we design the details in order to create the load transfer properly transmitted into the building. So what fabrication technologies are available in order to create this superstructure out of transparent materials, and how to control this from a quality point of view in order to optimize the processes. So first of all, just going backwards, we talk about bent glazing in that particular way in order to create this curvy line. So if we are talking about bent glazing, we need to take a step back and understand what bent glazing actually means. How can I bend a glass continuously, making sure that I do have the technology which is given to me in order to let this facade performing. So I do have different technologies from a glass curving point of view. I can cold bend the glass, I can warm bend the glass by lamination, I can hot bend the glass by gravity, and I can temper bend the glass. So all these different technologies are given to us in order to create this, this solution. So, and when we are talking about what needs to be done in terms of selecting one of these technologies, I need to dive into engineering. So what does the architect actually want? The architect wants to have a facade with the least of the distraction. And funnily, he also wants to have doors integrated into that facade. Well, I mean, sure, storefronts and lobby facades need doors. But in case of doors, we're already hitting the first problem. How can I integrate a door into a super transparent glass facade? Because I'm facing something like that, right? So my doors shall be fit into that facade, and I don't want to see anything like an additional joint. I don't want to see an additional steel mullion or an aluminum mullion. I really want to have a clean, crisp facade where I am putting a notch into the glass. So, okay, well, if I'm putting a notch into the glass, then I'm hitting a roadblock in engineering, which again goes back to the technology of which is given to me how to actually fabricate the glass. So there is a possibility of doing notches in glass that can be engineered, but from a technology point of view, it already crosses out several fabrication technologies like the warm bend slump glazing. Because when I'm thinking about slumping the glass, I'm thinking about annealed glazing, which is not tempered. And in those particular situations, I really want to have a tempered glass, which creates that strength, which I need in that particular corner. So I can go and use a tempered glass for that particular situation, and I can use an annealed glass for other situations, which I don't want, of course, because I could also, run into the danger of changing glass thickness, which I don't really want to achieve, because that might have a destructive vision at the end. So in that particular case, the architect wanted to hit on the spot, releasing this glass without any additional destruction. And that's why we were dialing into tempered glass, creating this kind of open a joint where this notch could have been correspondingly applied. So from a glass point of view, from a structural engineering point of view, just a few details. We were dealing with 2 times 10 millimeter heat strengthened glass for the vision glass, and 3 times 15 millimeter fully tempered glass for the fins, which are laterally supporting the glass. So in that particular case, temper bending was the technology to choose. And when we are talking about temper bending, we always need to think about, hey, that's fine, but what are the disadvantages of temper bending, right? So the architect wanted to have a clear and crisp surface without any destruction. The only problem with temper bent glass is that I am facing those destructions which may appear on the glass surface, which are roller waves and local bows, which may create a kind of distortion on the glass. So that's the only problem I do have with tempered glass. But it can be managed, basically. So in the quality control process, I need to see what I am fabricating. So this is what you see on a very typical tempered glass. It doesn't necessarily need to be a curved tempered glass. It could also be a flat tempered glass. So I do have roller waves, which are being as pronounced as depending on the glass thickness and on the temperature and the setup in the furnace, which are appearing on the glass surface. And usually the target is to minimize these roller waves as best as possible. In addition to those, in tempered bent glass, I do have another direction of roller waves, which are the roller waves which are appearing by parallel to the long edge, because I do have a tempering furnace and a quench, which actually is mechanically bending the glass and pushing the glass back and forth, which creates another roller which is appearing by parallel to the long edge of the glass, which is just creating another distraction on the glass surface. That's a problem because that's also very difficult to measure. That's very difficult to check from a quality point of view. So, and that's also why it is so important to actually create benchmark units in order to see and attract this kind of quality measurement process. So especially if we are talking about large glass, bent glass, temper bent glass, we are missing out standards and codes. So every time when we are missing out standards and codes, what are we doing in order to benchmark the quality? Because we want to create a kind of quality benchmark. We are creating benchmark units, full size, in order to actually set the baseline for the quality. So these benchmark units are visual mock-up units on one hand, but really quality benchmark units, which are creating a worst case. So these benchmark units are creating a worst case for the quality of the glass of the production for the project. And this is in relation to local and overall bows, latitudinal and longitudinal roller waves, curvature, radius tolerances, laminated edge offsets, and uneven anisotropy clouds. And this is so important because otherwise you cannot guarantee that the quality you are producing through the project is the quality which is acceptable for the client. The client and the architect needs to accept the benchmark panel, and then you are setting the base. And codes and regulations aren't anything different. There are only theoretical benchmark data which has been established over the years based on a corresponding database. So finally, we are also going into mock-ups, right? So of course, the mock-ups are usually first reflecting what the glass actually, how the glass looks like in conjunction with the adjacent glass, as well as gives us a good understanding about proportion, right? When we are talking about a 27-foot tall glass, what does it actually mean in proportion to what we are dealing with. And I love these pictures because you see the people, you know, fully grown up, and you see the glass behind. That gives you a good understanding of, you know, what kind of dimension, what kind of size we are talking about. And with all these details which are creating this additional workmanship, is giving the clients who are typically not from that engineering or architectural background a good understanding of what's possible and what kind of quality needs to be achieved. So, again. So, from a quality point of view into construction processes, it's almost also as important to take a look at, you know, how these large glass panels are being shipped, because many things can go wrong, basically. So we need to talk about packaging and creating, freight carrier selections, documentation, labeling, because as you have seen, this snake line which goes around this building is having different glass panels in a different kind of sequence going around the building, which all need to be labeled in order to make sure that you are installing the right panel at the right time. Handling of and tracking, monitoring is as important as the installation. So when we're talking about installation in a built environment, it is creating a problem, right? So how are we actually installing those panels? And you know, when you're approaching that from a construction point of view, you do have many possibilities. You know, simple possibilities are, hey, you're getting a mobile crane set up on the street level, and you're picking the glass out of the crate and installing it, right? But what's the disadvantage? You can probably only do that overnight, because it's a busy street, and closing off lines is very expensive and almost impossible. So in that particular case, we worked with a building integrated monorail system, which gave us the luxury of actually working all day long and picking up the panels from a loading area in order to create this kind of flow of installation from one point to the other, which was giving the owner a great flexibility to actually close off the building from outside as well. So, coming back to what has been sold to the owner. This has been sold to the owner, right? This is the architectural rendering. And only in a close collaboration with all parties, with all stakeholders, especially with the glass fabricator, it was possible to create this image and turn that into reality, where this is the built storefront or lobby glazing, which is very similar to what the architect as well as the owner had in mind. So that goes from owner sold to, this is so funny. That goes from owners sold to owners delivered, because that's what we want, right? At one time, we really want to deliver a good product with the technology which is given to us nowadays. And these, you know, before and after pictures, I love these before and after pictures, because that one was the lobby before, dark, you know, creating a not so nice environment. And this is the lobby nowadays, where it is creating a space for collaboration. So people don't necessarily need to go up into the offices. They can meet downstairs and pull the public environment into the building as well. So this is how it looks. That was a kind of retro-fit approach to an existing architecture, to an existing building in a dense area. And this opens the market not only to, you know, recycle materials, but also to reimagine the architecture which is built. Thank you.